You want to like, okay. Front one you make the thing blur, you know. Like one.
So just off all lah.
This one, okay. But then these people, they can't go to see, you know.
It's so bright.
Right, productivity not necessarily always have to be higher output. Alright? You can have in times where the economy is bad, your productivity can still go up. You can maintain the output. You can maintain the output, but you can reduce the input. Alright, productivity will still go up, am I right? Yeah? It's just like now in Singapore, the banks are all making a lot of money if you follow their profit and loss thing. Banks are making a lot of money. Why is the Singapore bank making so much money? It doesn't mean that we have so much more money to spend give to the bank. No, you notice that the bank have all introduced all this internet banking like whatnot. And you notice that the POSB branches have a lot of them has closed down already. Yeah, there used to be one across the road. Now no more already. So they save on the cost. They save on the input. So even though the number of customer doesn't increase, but productivity can still go up. Alright, so don't always think that productivity must go together with increase in the output. Alright, let's look at in the chemical plant. The best way to improve productivity in the chemical plant is to use automation. You can reduce costs, you can reduce input, or you can have better output, higher quality output. Alright? Reduce your rental, all this sort of thing. More quality output can be produced and you can sell. That means less rejects, all these sort of things. Okay? And you can reduce the input in the form of human. Alright? Human needs to have what? MC lah, leave lah, all this sort of thing. And human is very emotional. Certain day they don't perform their best of capability. Alright? So we can automation is important to productivity because of all these things, yeah? There is less chances of plant upset, am I right? If you use automation. Alright, because everything is controlled at that particular thing that you specify to the controller. So less upset means less temporary holding storage that you need to store the off-spec product while you figure out what to do with the off-spec things. So less off-spec production, less storage space requirement, less size, smaller plant size you can afford, less rental for the facility. Okay? One common example that you always see at any chemical plant is the DCS, distribution control system. You do this in your UO2, am I right? Yeah, in one of your lab, DCS, where everything can be controlled from the control rooms. The controller is located throughout the plant, but they can be controlled or monitored from a control room, as you can see here. Alright, all the sensors in the plant will tell you whether which one is progressing well, which one is not progressing well, and whatnot. And you can make changes if you want to from the control room without leaving the control room to the plant area. Alright, so each element of them has the sensors and actuators. Actuators are the mechanical thing that make the movement that move to either open the valve more or close the valve more. All these are the control mechanism, those things that really move, like how they open the valve. There must be something that turns the valve, am I right? Yeah. And controller will be like your PCI like that, all your PCI stuff that you see here. These are examples of control. You seen these slides in your PCI? Yes, really. So I won't go through too much of this. They are more or less the same like your PCI. In this case, you want to control the liquid at 200 degrees Celsius. So what do you control? How do you control it? Right? What will happen if you don't have any of these control strategy? If there's a high temperature, low temperature reactions, not ideal, right? So you need to know, you need to introduce a control system, as you can see here, which is automated in nature. Right? You must have a control system that can detect the temperature, which is your what you want to control, 200 degrees Celsius. It must detect the temperature, and then it must send a signal to the controller, which will compare it with the set point value, which is 200 degrees Celsius. Alright? And then if there's a differences, the controller must send a message to the control element, the final control element, in this case, which is the valve, to either allow more hot oil to go into the reactor there to heat up the liquid more, or to reduce the flow rate so that the temperature will not be too high. Okay, so this is your PCI or your PID controller, PID diagrams, piping and instrumentation drawing. In the PCI, you will learn that there is a control. You want the control at 200 degrees Celsius. The control system are the what? The sensor, temperature sensor, then the transmitter, then the transmission line, the controller, here all this sort of thing, and then your final control elements, right? So all these are part of your PCI. I'll go through it very fast because you learn this in your PCI as well. Measuring instrument. In your in your this controller here, there is two things here at the very first one. One is the measuring instrument that measures what you want, a temperature or pressure or flow rate or whatever. Okay, so it must be the first one here because it's in contact with the flowing liquid. So from here, there's two functions here. One is to measure the variable that you want to measure, in this case temperature, and then once it measures, there's a transducer inside this. The role of transducer is to convert the variable that you measure, such as temperature, and convert it to a physical value, such as current or voltage or pneumatic pressure, all these sort of things. Alright? And then transmit it to the controller via the transmission line. Alright? You saw from your PCI, if you have slash like that, it's pneumatic transmission line. If it's dotty like that, it's electronic signal line, electrical. The rest not so common. Okay? Most of it is the dotty line, which is electrical, or pneumatic, which is this. Okay, so obviously it can't transmit the message 200 degrees Celsius, am I right? It can't transmit, no, it has to change to something. Let's say 200 degrees Celsius is equal to maybe 2 volts, yeah? And then when it comes to here, it will compare it with the controller here. 200 will be 2 volts, so if it's more than 2 volts, maybe 2.5 volts, that will probably interpret it as high temperature. Okay, so transmission line transmit the physical value to the controller. The controller will compare it with the set point. Let's say 200 degrees Celsius is the set point, but inside there is set as 2 volts, because 2 volts correspond to 200 degrees Celsius. If there is a difference, then it will send a message to the control valve here, which is a final control element, to either open more or close more. Okay? That is your PCI. We'll go through it very fast because you learn the same thing in your PCI. What's the benefit of process control? Better quality. Yeah. You run it at the most optimum, so your product quality most likely will be more pure because the reaction will proceed to completion. So less impure stuff, all will proceed to completion. Any wastages? No. So less environmental issue, less cost also while the treatment, low cost, higher productivity, equipment protection, because everything is tightly controlled there, temperature will never go up too high. If it go up too high, it can damage your equipment, am I right? So never have that possibility because it's tightly controlled. Process optimization, everything else is nicely controlled. Your hot oil going in to heat it up, if it's not required, it will be tuned down. So your hot oil, the heat energy is not arbitrarily lost. And of course, safety, human error, less chances of runaway reaction because temperature cannot be too high, neither can it be too low, so less chance of a runaway reaction. Just now we talked about this already, the transmission line, transmission line. Most of the time it's either pneumatic or electrical signal.
I don't even have this slide.
The balloon, you see all these sort of things here?
No, balloon different. Oh wait, sure.
Is it the same, exactly the same slides as your PCI?
No.
So your balloon here tells you what they are. Alright, what are they controlling? Actual instrument tells the function and the nature. So in this case, you see a TT. TT tells you what they are already. FC tells you another thing. Right? The 117 is just the control loop number what lah. So in this case, this is the control loop number 10. That means you probably have another control loop doing other things from 1 to 9 before that lah. Alright? The alphabet, depending whether they are the first alphabet or the second alphabet, they tells different things. Alright? Like for instance, F. Let's say take T for instance. If it's the first alphabet, it will be temperature. Second alphabet, it will be the transmitter. Alright? Transmitter, which is just transmitting the value. Right? So if you say TC, it is TT, so it will be the temperature. You measure the temperature and then you transmit the temperature. Alright? If it's FC, first is F is what? F is the first alphabet, so it will be flow. Then the C will be the second alphabet. C or second alphabet will be the control, so the flow controller. Alright, so depending on the alphabet is tells you different things. If there is a line to it, if there's a line to it, like this one here, it tells you that this element here, this flow controller, can be controlled from the control room, the DCS control room. That means changes can be typed in from the control room, and then the changes will be reflected in that control room without you leaving the control room. Right? But if there is no line, that means the control room can only see the value only. If you want to make changes, anything like that, you have to walk all the way up to the plant and manually enter the value into the control elements there. Okay? And these are some of the symbols that we use in PNID diagram. We done this already. So can you identify the elements of the control system here, guys? What are the elements of the control system? This is the T. The first T stands for what? Temperature. Temperature measuring, right? Temperature measuring. Then it's T. The other second alphabet is also T, so it's a transmitter. Transmitter, which most of the time include the transducer, right? Which convert it to what? Temperature to air pressure, pneumatic here. Alright. Then this will be the transmission line, the pneumatic transmission line. This is your controller. The C is the controller, second alphabet, and this will be your final, your control elements, right? If the temperature is too low, it will ask the hot oil, it will ask the valve to open more to allow more of the hot oil to go in. Right? And all this is done automatically. So the temperature always is around 200 degrees Celsius plus minus a little bit only. Every single second of the day, 24/7, this thing is working. So it's always controlling the temperature tightly at around 200 plus minus a little bit only. Okay. Certain terms that you use in PCI, your control variable, your set point, your manipulated variable, your disturbances. Bear in mind that your control variable can be different from your manipulated variable. Right? Your control variable can be different from manipulated variable. Okay? Control is variable is what you want to control. In this case, it's the temperature of the liquid, 200 degrees Celsius. But your manipulated variable, is that the temperature of the liquid? No, right? It is the temperature of what? It is the flow of the hot oil they use to heat up the liquid. So they are two different things, right? You want to control the temperature of the liquid inside the tank, but you are controlling the flow rate of the hot oil going in to heat up the liquid. So they can be two different things. Disturbances, of course, will be anything that causes the temperature to be different from 200 degrees Celsius. Most of the time will be your incoming stream. Incoming stream could be too hot, incoming stream could be too cold. That will cause the temperature to deviate away from 200 degrees Celsius. Now, can you tell me what is the, everything is answered, it's all there already. Can you tell me what is the control variable here? What's the control variable? What do you want to control? You want to maintain the temperature in the tank to be 200 degrees Celsius, am I right? So the temperature of the fluid inside the tank, that's the control variable. But what is the set point is set at what? 200 degrees Celsius. The manipulated variable, what do you manipulate to ensure the temperature of the liquid inside there is always 200? The hot oil flow rate of the hot oil. Not the temperature of the hot oil, but the flow rate of the hot oil. And disturbances, how can the temperature not be 200 in the first place? Must be the inlet reactant flow, am I right? So the inlet temperature could vary, could be more than 200, could be less than 200. Okay? Alright. We go quickly through this one because it's, you learn this again in your PCI. Beside PID, you also depend on process flow diagram. Process flow diagram is much simpler like this. Alright? It gives you an aerial view, the overall view of the processes in your plant. Alright, so you can see here there's a heater, there's a reactor, there is a distillation unit, all this sort of thing. But although it gives you a better view of the processes that's happening in your plant, after this unit process, it goes to where. But you can see here, it's much simpler. So it doesn't have things like the what? It doesn't have what? It doesn't have minor details like flanges, bypass line. It doesn't have all the control loops, all these sort of things. Yeah? But it does give you an overview of the process. Right? Some of the symbols that they use in PFD diagram. This is always a heater. Alright, a hot oil heater. This is like your distillation unit, distillation column here. This will be your heater, heat exchanger like that. Okay? More of these PFD symbols. You learn this in your PCI, so I don't stay here too long. Now, can you just tell me the answer for this quickly? Is it distillation column?
Distillation column. Or pipe column. What is distillation column? Pump. Centrifugal pump.
What is it, guys? It is a pack column. Pack column with the X inside there. Pack column is like your pack. That means inside there is packed full of things. What's the purpose of a pack thing? To encourage interaction, yeah? Make life difficult for the liquid inside there to flow. So they have to flow through a convoluted route, so the mixing time is longer. You have two liquids, yeah? Either gases or liquid, most of the time liquid. One is flowing from the top, one is flowing from the bottom. So they have to go through this, turn here, turn left, turn right, so more mixing time, more interaction, more time for maybe one solvent to move to another liquid. Right? You use this in your UO2's liquid extraction column. Okay, guys? Thanks. Anything to copy here?
No, I guess.
Also provided. Terrible. Everything is there. Okay? Next way, how can we improve productivity again? We can also do what, guys? We can reduce our waste, am I right? Reduce waste. Reduce waste means what? Reduce your raw material costs. Am I right? Because waste always comes from raw material. You also reduce your treatment costs because your waste and generate need to be treated. So you save two things, raw material cost and the treatment cost. So on the output divided by input, the input goes down, productivity goes up. Alright? Waste reduction is a big thing. You should monitor your waste from the moment you generate them until finally you dispose of them. They are the one that you are familiar with is always treatment. but they can be more than just treatment when you deal with waste. Rather than treat the waste, you can exchange the waste, you can reuse the waste, you can recover the waste even. So not necessarily always have to treat it until the discharge limit and then throw it away. Okay? So the one that you're familiar with is the waste treatment, coagulation, flocculation, ion exchange, all these sort of things. Yeah? But you can reduce your waste by, in the first place, conducting a waste audit. Alright? What is a waste audit? What is a waste audit? Waste audit is that you try to find out which part of your processes that generate the most waste. Alright? And then, once you identify the stream that generates the most waste, then you try to implement measures to reduce the waste generation from this main waste generator. So you must identify your waste stream first. Then, once you know that a lot of waste coming out of this stream, then trace it back to the source where the waste is coming in, and then prioritize it. Maybe you have a few processes that generate this waste. Then which one is producing the most, right? And then once you get it, then you know this particular process. Then sit down and think: is there any alternative way that you can reduce the waste generation? Because it's the most one is generating the most. How can you do that? Well, you can you substitute some of the raw material? Use a raw material that generates less waste. It doesn't contain those contaminants that need to be treated, specifying those discharge limits, yeah? And once you got the alternative ready, then obviously you need to implement it. Alright? Implement it and then track the changes, see whether it's effective or not. Right? So that's waste audit. You can also use source reduction. Source reduction is a very common thing that a lot of companies use. Yeah. What's the noise here? You all have like reduced by half really, since last week. But the noise volume is higher than last week even. Why is that so? There's only one solution, which is waste reduction, source reduction. Can some of you don't come next week again? Yeah, you can reduce it further. Alright? You have the e-lecture. My e-lecture, you don't hear Zexu scolding you, yeah? It's all sanitized, welcome everyone, blah 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 blah. Okay, so it's like, you might prefer that.
No.
Okay, so if you want to be here, let's not make so much noise so we can finish off the quarter. What's my quarter today? My quota today is I have to finish everything. So as and when I finish the entire topic 1, we call it a day already. So if you cooperate with me, I can finish it faster. Right? So source reduction, very important. Source reduction, very important. It's something that is practiced in all the company. What is source reduction? As the name suggests, it's a reduction in the waste at the source itself. Alright? How do you do that? As the source generator of waste, how can you reduce source? How can you reduce the waste generation? Well, you can either change the input material, or you can use technology, or you can just change the way you do things. The way you do things, the protocols, all this sort of thing, your management system and stuff like that. Right? For instance, input material, you can use what? Besides using, like a common example would be like IKEA like that. Last time IKEA used to provide their own paper, am I right? The paper wrapper. Yeah? Now, then later they all change to what? They get the old newspaper from you all, am I right? And then they which is a waste actually. So rather than they use a fresh material as a wrapper, they use a waste material as a wrapper. But in chemical plant, how can you change? How can you do source reduction in the form of changes in input material? Well, you can use purer material. Yeah, there's always these two things: lab grade and industrial grade. Alright, industrial grade purity is not as high as lab grade. Yeah, so if you use the industrial grade one, there's more impurity. This impurity doesn't take part in reaction, am I right? So it will appear out in your waste stream, and then you have to spend more effort, more cost treating the impurities. Right?
Wasted my
Using
money,
deionized
sir.
water and plating,
I mean, the
all
movie
this sort of
wasn't
thing.
that good.
Rather than use deionized water in, let's say for instance, boiler sort of thing. So less hardness in the water, less scales formation. Scale formation, later you have to put in more cost to treat the scales and stuff like that. Alright? You can use substitution using something that is less toxic. Alright? To perform the same function. Same function, yeah? Like last time, we use what? Dichromates. Dichromate is a corrosion inhibitors, right? But dichromates is very highly oxidative, so it's a mutagenic thing. So we can replace dichromate with phosphate, right? Dichromate, the control is very tight. You can't discharge dichromate as and when you like it into the waste stream. You need to treat it until a very, very low concentration. You can use dilution, which is not a very good thing. Or you can do housekeeping to reduce waste generation in the source. How does doing housekeeping can reduce waste generation? What is one of the bad things of housekeeping they want to address? Like wet floor, am I right? Spillages, all this sort of thing. Spillages, all this sort of thing actually are your waste, am I right? Your raw material is being wasted, is spilled on the floor. So if you have good housekeeping, you ensure no spillages occur, then it essentially is less waste generation. Yeah. In changes in technology, the other part about the changes in source reduction is change in technology. Right? Nowadays, one common one will be your aircon. Last time we used the what? The old one where the compressor on and off, on and off, on and off, all this sort of thing. Every time the compressor kick starts, chances of damage to the compressor is there, and it's also very wears out the compressor very fast, and it's also costly. So nowadays we use inverter technology, where the compressor is always operating at very low requirement, so it's always humming around. Less damages because it's always operating at this constant thing, and less energy consumption as well. Right? Other things like use automation, use email rather than paper, all these sort of things. These are technology. Could be just the way you operate. Don't have to invest in technology. Don't even have to look at your raw material. You can just change the way you do things. Like you can organize your production plant so that material from here don't have to travel very far to the next stage of production. Because if you travel very far, you might spill it, you might overturn the trolley, then all become waste, all become rejects here. Or you can use management system, like for instance JIT, just-in-time production, where you bring in the raw material only when you want them, alright? And you produce just enough of a product that the customer wants. So you don't bring too much raw material, so in the case of no repeat order, the raw material doesn't go to waste. And you also don't produce too much of the product in case no repeat order, then that product becomes waste eventually when it becomes obsolete. Yeah. And JIT also helps with your management of space, your rental space, all this sort of thing, because you didn't bring a lot, so you don't need a big warehouse to store the raw material, or a big warehouse to store your product. Okay? So that is your what you call that? Your human aspect of production. You can have an EMS also, environmental management system, which helps control your waste generation to bare minimum, so you don't have to invest so much in treatment of excessive waste. Right? So that is source reduction. Yeah. Next one is what? Under the waste reduction, you can have waste exchange also. Rather than treat the waste, rather than keep treating the waste in your waste treatment plant, that waste generated you can send to another company. Right? A lot of time, believe it or not, your waste is actually very valuable, right, you know? Yeah? Other company may want it. Some people pay money for your waste, you know. Alright? So you can exchange the waste with another company who wants it. Right? That helps reduce the disposal cost for yourself. Okay? Such as all these examples. If your company generate a lot of alkaline waste, you might want to give it to another company which generate a lot of acidic waste. So when you throw in alkaline, it actually neutralizes their acid waste. So they don't need to buy alkaline to neutralize their waste. They can use your alkaline waste to neutralize their acidic waste. You can do the 3R thing. You can do the 3R thing. Recycle the waste or reuse the waste. Alright? There you go. There's many ways that you can recover waste in the chemical industry. You can reclaim it like this way here. In your circuit boards, for instance, what are all these lines here? What are all these lines? Those are your wires, am I right? They are copper wire actually. Your circuit boards, which is the heart of every electronic component, it started off with the entire piece as copper, you know. On the surface, all here are all copper. Alright, and then they etch away using copper etchant. To etch away so that you get the residual here. These are the remainder copper, which act as wires and whatnot. But the rest of it, all you can see here, they are all free of copper already, no more copper already. So they have been etched away by copper etchant. Okay? But that also tells you that copper etchant will contain a lot of copper, am I right? Because it dissolves the copper away from here. So can you recover those? Copper? Yes, you can. Alright? The spent etchants. Essentially, it is this one here, copper solid of your circuit boards here. React with the copper etchant, and both of them become copper plus. Alright? It's a reversible reaction. If you know this one here, this is your spent etchant because the original etchant must be copper 2 plus. So it can dissolve the copper, so both of them can become copper plus. You can oxidize this copper plus back to copper 2 plus. But you need an oxidizer. What's your oxidizer? Hydrogen peroxide. So when you oxidize it, that means introduce the oxidizer in the reaction, shift to where? Shift to the left hand side. If you shift to the left hand side, you not only get back the Cu2 plus as an etchant, but you also get what? Copper ingots, solid. So that copper ingot you can sell. Yeah? So a lot of people, when they have a spent etchant, a lot of Cu2 plus, they don't know what to do. They actually pay money for people to take this off their hand. So all these waste recovery people will come in, and then all they have to do is just throw in oxidizer and you get back fresh etchant and copper ingots, okay, which you can use for your process again. Okay. How other ways can you recover waste? In chemical industry, how can you recover waste? Well, we use a lot of solvent, am I right? We use a lot of solvent. Sometimes our solvent, let's say acetone, chloromethylene, all this sort of thing, they get contaminated by other things. Alright? Like your UO2, you use the liquid extraction column. There is TCE. Alright? TCE, inside the TCE there is propanoic acid. Propanoic acid is what you want. But it's inside a solvent called TCE, which is harmful. But you want the propanoic acid because propanoic acid can double up, can be used as vinegar and stuff like that. How can you extract the propanoic acid from all this solvent? Well, you can either use liquid extraction column, introduce a liquid, in this case water, in which propanoic acid is more soluble in. So the propanoic acid will migrate from the TCE into the water. Or you can use distillation process. Distillation process works based on what? Distillation process based on boiling point, am I right? You have different components. You got solvent, you got your solutes, all these sort of things. All of them have different boiling points. So if you can separate them according to their boiling point, and you can purify them. Okay. It's just like our crude oil. Our crude oil, if you ever see a crude oil, it's like sticky black color like that one, no? It's totally useless because it contains a lot of foreign stuff inside there. But if you can separate them according to their boiling point, you can get your jet fuel, your kerosene, all these useful products from there. Right? You can use electricity to separate the, let's say for instance, photograph waste also. Right? Like how they develop pictures and all these sort of things. They use all this silver, all this they contain silver. You see all those how they develop negative last time. You can use electricity because the silver will be attracted to the cathode, right? We won't go to the details of the electrochemical reaction. We can use we can play around with the left hand side, right hand side of the equation. You know, if it's a reversible reaction, we can move the reaction to the left, to the right, like in this action case. Okay, this is also important. Right. Next one, we're done with the B. How else can we reduce the? How else can we increase the productivity in the chemical plant? What can we do? We can also reduce raw material costs. How can we reduce raw material costs? One way is of course to reduce wastages. If you have less waste, then obviously you use less raw material. You can also source around for cheaper raw material. Right? Last time when we want to buy something, we always put out advertisement in the newspaper, but we only advertise for supplier in Singapore only, right? Yeah. Nowadays, when a company wants raw material, they put it out in the internet, right? And the whole world can see, right? And the whole world can bid for this business. So every company in the world will submit as cheap as possible, quote as possible. So that way you can reduce your raw material costs. So put it out in the internet rather than local news. You can increase your conversion rate. If your conversion rate is to completion, then you get more product. Am I right? More product. Okay, there you go. So if your conversion rate is only 90%, what will happen to the 10%? Those are actually your raw material that never get reacted away. Am I right? So they will become impurities and they become waste. So how can you increase your conversion rate? You can first of all react them in a stoichiometric condition. So if 1 mole react with 1 mole, make sure it's 1 mole, 1 mole. Don't put 1 mole and 2 mole. Yeah, because then this one will be excesses and they will become a waste. You can make sure they proceed all the way to completion by reacting them at optimum condition. What is the best temperature, best pressure, all this sort of thing, best stirring speeds and stuff like that. So make sure that the conversion rate is 100%. Correct? And the rest is like stoichiometric condition and QC checks. Okay? Question so far? No, Can you answer this question, guys? My next lesson next week, whatever happen, don't skip my next lesson next week. If you get run down by SBS bus, still crawl back here. Right? Whatever, because next week is very important. Next week, things is so difficult to understand. Right? It's so difficult to understand. You can try to follow my e-lecture, but it's quite abstract. Okay, so make sure you attend next week, Okay? Just next week only. After that, you all can continue listening and play through the absent of my lesson. But next week is very important. And because next week one is also comes out in section C of your term test, which is like 20 marks question. Term test is 70 marks. If you do well for calculation, it's 20 marks.
Okay.
You write your name, it's
Yeah.
another 10 marks, so 30 marks already. Right? And you write something nice that Zach Su is the best teacher in the world. You get extra 5 marks, then you pass already. Yes, yes, yes?
Okay.
Tutorial start next week lah. Yeah? We say week 3, right? Yeah, so next week start
cool.
tutorial.
Wait, Joe, you never have the.
Yeah.
What's
Okay, bye. I love you.
Then we don't know which day.
I tell you lah. I tell you lah. Week 3 lah. Week 3 tutorial start. You want to study guide? I can load it out for you all lah. But study guide is something that I prepare before the term starts. Am I right? When the term starts, things will happen. So why don't you listen to the horse mouth?
How to know?
Ask on your friend. I'm sure you have friends. Am I right?
No, they would like to be.
Yeah. What kind of friends you have?
Snake, all snakes.
Okay. What is the answer here?
B.
Answer is B. Everything except waste exportation. Yeah. You know now in the world, what's the favorite thing that all countries likes to do now?
Export.
Every country likes to export their waste away because we generate so much waste, you know. Alright. And you think you are doing a good thing, you know, guys. All of you, I see you are so diligently take your plastic waste and you put in where? You go and put to the plastic waste bin. You are so diligent. I'm so touched. But are you helping the environment? You're not helping the environment because a lot of countries they'll just take this plastic that's collected from this plastic bin there, and they will just export it to another CMI country, a third world country where the law is very lax. Alright? So these are the games that a lot of developed countries are playing, you know, and a lot of third world countries are being affected because of all this selfish behavior of a more developed country. Yeah? Plastic waste, is it easy to treat a plastic waste?
No.
It's almost impossible to treat plastic waste, you know. Because you can't, if you burn plastic, you create dioxin. Dioxin is so toxic. If you're going to treat dioxin, you must put in a lot of treatment costs. You know what's the discharge limit for dioxin? Nano ppm, you know, 10 about -9. Yeah, how in the world are you going to treat something to below -9? Yeah. So a lot of countries they rather not treat it and export it to third world country like Malaysia or this sort of thing. You know, they send the container load of plastic to all these third world country where they just bribe the official there, stuff like that. Right? And guess which country are exporting their waste away? Developed countries such as what? Western country like Europe lah, America lah, that every day will lecture all these third world country about how important it is to conserve the environment. But behind them, they are doing all this sort of thing. And another developed country that is also taking part in this shenanigan is this country called Spencer. Right? How much waste is Singapore exporting? Only 7% is recycled. Tell me what happened to the rest of the 93%?
Presents.
37 tons of it was sent overseas to where? India lah, or Southeast Asia, India lah, all this semi-space and whatnot. Right? Some may treat it, but some third world country, if Singapore can't treat it, you think this developed third world country can treat it for you. So it's like you're just like, yeah. There you go. So it ends up in third world country, and you know what third world country do? Third world country will just do what you want to do lah. They'll just burn the plastic lah. And because the law there is so lax, nobody will kind of enforce it. So all this dioxin will go to the environment, and then the third world country environment will get sick. Yeah, there you go. So no waste exportation, please. So sometimes you all take your plastic waste and throw into the bin. You think you're saving the environment. You are contributing to the pollution. You know. Yeah. Yeah. How can what else can you do, guys, to improve productivity in the chemical plant? You can produce more output, am I right? You can produce more output. How can you produce more output? How can you produce more output? Well, you can reduce your reaction time. You can reduce your reaction time, am I right? If it's a batch cycle process, then you can reduce the batch cycle production time so you can produce more, alright, in a year. So more output, more productivity. Alright, there you go. If you can produce more, then the customer, the improvement in quality will also be more. Because when you produce more, customer get the thing faster, they can feedback to you faster, you can make fine tuning faster, and the product quality improve faster as well. Okay. How much can you produce a year? How much can you produce a year? It's obviously controlled by this simple formula that is, what is your reactor size? What is your reactor size? Maybe 5 tons. It means you can produce 5 tons of product every batch. Multiply by how many batch you can run 1 year, right? So if you can produce 20 batch in 1 year, each batch is 5 tons, so your annual production will be what? 100 tons, am I right? So makes sense, yeah? So you can either look at the reactor size or you can look at the rate of production, right? As you try to produce more and more, you are obviously going to run into bottlenecks. This one here. There are 2 types of bottleneck. One type of it is that limit the number of batches that you can produce a year. This is what we call time bottleneck. This is time sensitive, right? Per year, right? Time sensitive, so it will be the time bottleneck. This one or the other one, you can produce limit the size per output. This reactor only allow you to produce 5 tons per batch. So this is the size bottleneck. Can you try to run it at 6 tons per batch? Yeah, is there any way you can do it? Maybe there is way, or whatever it is. The one that's limiting the amount that you produce per batch is what you call size bottleneck. As compared with the time bottleneck, how much can you produce per unit time? Alright, let's look at this one here. You have a unique process, this tree here. After 3 hours, 1 hour here, 1.5 hours, 0.5 hours here. After 3 hours, how many tons of product this thing has produced? 3 tons, yeah. Which is the bottleneck here? Which is the bottleneck? You only look at the last one, like they say 0.5 hours give you 3 reaction times, then 0.5 times, where's the bottleneck here? 5 tons. So unit process B is the one that takes the longest time, right? So it's time bottleneck. It takes the longest time to run. Which one is the one that produces the least one? This one here. So C is the size bottleneck, it's the smallest reactor. Even if this one is done producing, not all can go into this. Not all can go into this reactor here. 6 tons must take its own sweep time to go in. Take its own sweep time to go in, yeah. Okay. So that's some of the bottleneck definition, yeah. How can you solve for time bottleneck? How can you solve for time bottleneck? You can have more equipment, right? You can have more equipment producing it parallel. Okay. You can have, let's say this one is time bottleneck B here. It's taking so long, right? You can have another unit process B running parallel to it. So within 1.5 hours, you can produce rather than 6 tons, you can produce 6 tons, and 6 tons you can produce 12 tons. Alright? Or you can have a staggered mode, meaning to say you don't wait for this one to finish before you pump it in. Right? You can do it at the same time. While this one is reacting, you can start producing the new batch of product in here already, staggered. You don't have to. This one all be waiting to go inside here, right? explanation is here. For size bottleneck, you identify the vessel that is already running and is max already at the highest size utilization. That will be the reactor that is being stressed out. It's running at the best that it can already. Okay? Then, once you identify it, you can either add more vessel to it. Maybe you can have another one of this C here, or you can run it at maximum volume. Maybe it can 3 tons here, but maybe you can run more. Maybe you can top up higher a bit. Yeah, so you can run it at higher volume. So if it's maximum volumes here, why are you running at the blue line here? You can run it more, okay? Right? So that is size bottleneck. Or you can, what else can you do? You can move, why is this thing at 1.5 hours? Why does this reaction take 1.5 hours? Maybe because when you charge it in, then you need to heat it up, am I right? You need to heat it up, so the heating takes a while. Maybe the heating takes 30 minutes to heat it up with the optimum thing. So you can take out the secondary operation, take it to outside here like this, so that when it's flowing into here, there is a heater here already to heat up the liquid entering the reactor. So by the time it goes inside there, it's already at the reacting temperature, and the reaction can start already. Okay? If you put the heater inside there, it's trying to heat up the bulk liquid 6 tons. It's going to take a while, am I right? But if you put the heater outside here, every time when it's a little bit 5 liters per hour flowing through, it's easier to heat it up faster, am I right? Yeah? So you can move the secondary operation outside. So rather than 1.5 hours inside here, 30 minutes of heating is really conducted outside when it's at the same time that it's flowing in. So there is no time wastage. And then you can reduce the timing to 1 hour. Okay? So that is another way that you can solve for time bottleneck. Right? How else can you reduce back cycle time? Well, you can use, maybe how can you accelerate the process? You can use low pressure or vacuum. Last time my batch process we used vacuum. What's the purpose of using vacuum? What's the purpose of using vacuum? When you use vacuum, what happens to the boiling point? Lower, am I right? So the thing will boil faster. Alright? Why do I want to boil something? Let's say for instance, if I want to remove water. Let's say my byproduct of my reaction, it produces water. What will water do to my reaction? It dilute my reaction, am I right? So my reaction rate will go down. So if I can introduce a vacuum or a low pressure, I can suck out the water vapor, which vaporize very easily because the boiling point has dropped. Alright, so I can suck out my water vapor, and then the concentration is more concentrated. It can react faster. Okay? This one way. Prevent dilution of the chemical by sucking out the water vapor. That will cause dilution. What else? In your, for instance, your waste treatment plant, you study IWT. Have you studied chemical? Some processes involve waiting for the thing to settle down. Some processes involve things settle down. Alright? Like your muddy water. Can you discharge muddy water into UV sewer? You can't. So you need to let the suspended solid settle down first. Most of the time, we only depend on what to settle down. Gravity, am I right? Gravity, but sometimes gravity is very slow, especially the solid is very small. Can you accelerate the settling process? Yes, you can using centrifuge. Centrifuging can, heavy thing press to the side, all this sort of thing. So rather than use gravity settling, you can use centrifuge settling. Alright? What else can you use in chemical plant to accelerate the process or reduce the batch cycle, increase the reaction time, reduce the reaction time by speeding up the reaction? We can use catalyst. Alright? Catalyst is supposedly the best thing in the world. It increase the rate of reaction, but what? it increased the rate of reaction, but it did not get used up. So theoretically, it can be used forever. But in real life, it doesn't wanna. In real life, the catalyst, because catalyst is always surface reaction. Yeah? After a while, the surface of the catalyst get contaminated. Alright? Oxidized, or sometimes other chemicals sits on it, then the active site cannot be used to promote the reaction. So although but whatever it is, during the time when it can be used, it really can accelerate the reaction, so it can produce more output. Okay? Can you answer this question? Higher size utilization, that means you're running this this reactor as hard as you can really. That means it must be like everybody wants to go into this reactor. So what can you do once you identify this reactor? It is the rate limiting steps really, am I right? It is the rate limiting steps really. You cannot put any more, it's really producing. So you once you identify this size bottleneck, then you can take action against it. Maybe produce another one, introduce another similar reactor, or see whether you can increase the volume of this reactor and run it a little bit higher capacity, rather than 5 tons, you run it at 6 tons. Yeah. Okay. Last way where productivity can be improved in the production plant is by higher what? Higher environmental, health and safety performances. How does better safety and health performances help improve productivity? Safety and health also related to productivity, man? Well, in the sense, yes, because why? It helps reduce cost. And you know cost is input of the productivity. Productivity is output over input. So if you can reduce cost, you can reduce input, then you can have higher productivity. What kind of cost? Well, if your worker die or get injured, you need to find some replacement. So there's a worker replacement cost. There's a compensation cost. If they get injured, there's WICA. Remember your WICA? No, you don't remember WICA because you haven't studied WICA yet. Year 3 you study WICA. Right? It's about injured worker need to be compensated. You can't just throw them into a longkang and run away. Right? Then cost of plant shutdown. When if you have an EHS accident, like shell fire like that, 6 months no production. So totally the cost, compensation cost your customers, all this is high. Or authority will come and fine you for all your defect, shortcoming that leads to the accident. So all this adds up to your cost. Environmental as well. If your environmental performance is very good, chances are you have less accidental release into the environment, right? If there's accidental release, like fishes start turning up dead, all this sort of thing, and they trace it back to you, then probably the NEA will ask you to clean it up or whatever, and even fine you after that. So less environmental cost, cleanup cost. Okay. Remember your OSH. We have this OSH legislation is what? WSH Act. WSH Act is a proactive safety legislation here, where we ask you to, even before the accident happened, we ask you to find out the hazards of your processes, and then find out the risk level of your hazards, those identified hazards. If the risk level is very high, take action to introduce new control measure, additional control measure, such that the risk level can go down from medium hazards, medium risk to low risk. Alright? If the risk level goes down, the chances of the hazard manifesting itself as an accident will be reduced. Yeah? So even before the accident happened, you already take a control measure, additional control measure to reduce the chances of the accident from occurring even. Yeah, so that is how you can reduce accident in the workplace. And by having a high EHS performance, less chance of less input costs, so higher productivity. Right? Last question, and then we are done for the day. Make sure next week one you must attend. Even you attend also, I think you also go La La Land. It's quite abstract next week, but it's very important because you come for your term test. There you go, we finished in 1 hour, so kudos to you for not making too much noise. And because you are so well behaved now, you earn yourself 1 hour to do work, to do your projects, am I right? Yeah, do anything that your heart desires. Answer is? Answer is? How does help improve productivity in the output? No, so not only the cost, but you can also help with the output. If workers are injured, can they perform at their best? No, right? They buy car, buy chew, all this sort of thing, so they only got one hand to do work. So their efficiency is not there. Right? So uninjured worker can perform more efficiently, produce more output, or output with less rejects. Okay? Alright. So that's all for today. Thanks to you for not making too much noise, and you can finish it soon.